Hi, my name is Mary Ellen Summerlin, and this is what we call our aquifer model. Actually, it's a model simplified of the whole water cycle. We see a cloud, the surface of the earth, a lake, a river, wells underground, and many layers of rock, sand, clay, and gravel deep under the surface of the earth. Aquifers are just those layers that hold water and allow water to pass through them. The layers that don't hold water, don't let water pass through, are called aquitards. This model can show us something very important about water on our planet. It's a closed system. Every bit of water we have now is water we've always had. There's no such thing as new water. The water we'll drink today is the water dinosaurs drank millions of years ago. Every drop on the planet is at some stage of this water cycle. It's evaporating, condensing, and precipitating. Evaporating, precipitating, over and over, recycling itself forever. Aquifer water, which is in storage under the ground, enters this cycle when it discharges through springs into streams, rivers, lakes, and then can evaporate into the sky, or when we pull it up through wells and use it, and then it can evaporate. Then it can condense and precipitate with the rest of the rain. When rain falls, lots of it runs off the surface of the earth into the lakes and streams, but some of it percolates down through the topsoil into the aquifers and recharges them. So we have recharge and discharge of the aquifers as part of this whole cycle. We see that surface water and aquifer water are really all the same water, constantly recycling, part of our finite water cycle. In Kerr County, we have lots of aquifers. They have names like Fort Tarrant and Hensel and Cow Creek, and we have a few aquitards like the Hammett. As in the model, they're made of different materials, and the water in them is different in quality. Some very good for drinking, some not so good. Now, water in the aquifers is always moving. Water in our model is clear, so I'm going to add a little color to it so that you can see the movement more dramatically. I think you're going to notice two things. One is that water moves at very different speeds in different aquifers. The other observation is that the water all moves in the same direction. This, in both respects, the model is reflecting Kerr County. Water moves on the surface, water moves downhill. We all know that. Underground, we talk about water moving from areas of high pressure to areas of lower pressure. In the model, this is the high pressure side, this is the low pressure side, so that's why all the water runs that way. In Kerr County, the water in our aquifers generally runs from northwest to southeast. But we can always count on water. We'll see this again and again in the demonstration. It always moves from a place of higher pressure to a place of lower pressure. A big difference between the model and the aquifer is this stone aquifer, this rock aquifer. In the model, it's on the bottom. In real life in Kerr County, it's up here on the top, right under the grass and the topsoil. In fact, some places it sticks out through the grass and the topsoil, as we all know. We call it the Edwards Plateau aquifer. We've grouped our aquifers together for easy reference. One group we call the Edwards Plateau, another the upper, the middle, and the lower Trinity Aquifers. All of them refer to many layers. These rock layers that are right up at the top in Kerr County are an abundant source of springs. They furnish ranch homes, their wells, livestock tanks, but most importantly, they furnish and support the Guadalupe River. The Guadalupe River in this county is a source of irrigation, the source of industry, the source of our recreation and camp businesses, and the drinking water for the city of Kerrville. So you can see that this Edwards Aquifer is very important to our county. Now this rock, limestone, karst aquifer extends far past our borders for thousands of acres to the north and west. That means that when it rains north and west of us, this wonderful aquifer that moves water, as you saw, rather quickly, is all coming our way. And that's why when we had our drought that lasted several years and all the rain seemed to miss Kerr County, the river never went dry. It was feeding off all that rainwater that fell north and west of us and moved our way through the Edwards Aquifer, or the Edwards Plateau Aquifer. We want to make a distinction between the Edwards Plateau Aquifer and the Edwards Balcones Fault Zone Aquifer, what we call for short the Edwards BFZ. That is a part of the aquifer that is down faulted 3,000 feet. And under the city of San Antonio, for example, has resulted in giant caves full of water. Even divers have been in them. We think in Kerr County, our Edwards Plateau Aquifer looks more like this model. That is, smaller passageways through the rocks and little pools, but very rich in water for us. Droughts and floods are very common in our region. When we have floods, the rain comes too fast and everything fills up. The lakes fill up, the rivers, the reservoirs. Sometimes the rivers even do damage with the heavy water. When the surface features fill up, so does the aquifer, and the water rises in the various aquifers and in the wells in them. When the rain stops and droughts happen, then the water levels recede. We can see it obviously on the surface, and even underground, we notice that the aquifer levels, as reflected in their wells, drop down. We need to think of our aquifers as our savings account for water. They can help us level out these natural fluctuations of rain, flood, and drought. But we have to remember to keep enough water in reserve. During times when the river is low or when demand exceeds what the city is permitted to withdraw from the river, the city of Kerrville relies on wells in the lower and middle Trinity aquifers. These are extremely rich aquifers in our county and support all the big commercial wells, the ones that might be used for industrial purposes or for water supply companies, private water supplies that supply household water to many households. There are also some residential wells in these aquifers. This model does a good job of showing us how wells work. Water fills a well because the pressure in the aquifer is higher than the pressure in the well bore. In fact, from the model, just as in real life, you can see that the pressure is so much higher in the aquifer that the water rises above the top of the aquifer. And that's what happens in real life too. Now, a pump works on the same principle as a drinking straw. We draw the air out of that pipe and the water rushes in to take its place. When we pump our well, we may notice that the water level drops a little bit, but pretty soon it comes right back to where it was. That's because we can depend on water moving from a place of high pressure to a place of low pressure. It'll always do that. I'm going to pump this well again, but this time I want you to look at well number 7, a well that's also in the same bottom aquifer in the model. When I pump well 1, you noticed that the water dropped in well 7. This is called the interference of wells. The well with the biggest pump will draw the water from its cone of depression all around it actually taking water out of other wells. One of the most important functions of the local groundwater conservation districts in Texas, like Headwaters in Kerr County, is to regulate the spacing of wells and the size of pumps so that this interference does not cause trouble. Another very important function of the groundwater conservation districts is to monitor and limit how much total water we withdraw from our aquifers. This is very important because aquifers can actually be depleted. Now, it sounds like water is always coming in and always going out, so how could an aquifer deplete? That makes sense until you think about pumping and the speed at which we withdraw it. There have been age-dating studies done in Kerr County that show that the water in the Trinity Aquifers is very old as 20,000 years. That means it has moved in here very, very slowly. We believe that it does not recharge from rainfall in Kerr County, but moves in from around us. If we pump faster than the new water is coming in, we can actually use up that aquifer and for all practical purposes deplete it. Our wells won't work anymore. So it's very important for us to keep that in mind. In fact, we have records of wells that go back to the 1970s and have been continuously monitored since that time, and they show a slow, but a steady decline in the level of water in our Trinity aquifers. Going forward, as our population continues to increase, we're all going to have to remember and adjust to this hard fact. Aquifers, like bank accounts, can be used up. Naturally, since we live in a semi-arid place, it's smart to conserve water all year round. Rainwater harvesting is a great idea. The city of Kerrville uses another wonderful, innovative idea that you can visualize very well from the model. In wintertime, the city is allowed to treat water from the river that is in excess of what is actually demanded by the citizens of Kerrville because they're not doing any outside watering to speak of. So the extra water is inserted in what are called ASR wells, Aquifer Storage and Recovery Wells, actual wells into the lower Trinity aquifers that insert treated river water. Then in summertime, when demand is high, sometimes doubles when people begin to water their yards all the time, that water, which has hardly moved at all in this slow-moving aquifer, is available, recognizable because it's chlorinated, and available to be drawn back up and used to meet the demand. A very good system. I want to show you one more thing with the aquifer model, and that's how aquifers can become polluted. Now, they're underground. You would think they would be protected from pollution. But think about underground storage tanks, the kind maybe under gas stations. Not supposed to leak, but they might. Think about septic systems that are maybe not so well engineered or too close together. They can leak. Sometimes just lazy citizens who, instead of properly disposing of herbicides and pesticides and automobile fluids and paint, decide to just dump it on the ground. Very soon, we see that pollution sinking into the aquifer. And don't forget, here, it's that fast-moving karst aquifer that's on top. And which way is it going? Right to our river, the source of our drinking water. We need to be very, very careful about polluting our aquifers. Water is essential to every aspect of our lives: our health, our economy, agriculture, industry, energy production, technology, and the very balance of nature on which all life depends. Wherever you live, find out where your water comes from and commit yourself to protecting this vital natural resource. Thank you.